Welcome back. This is Mr. Hassan's Maths channel, and I'm answering a question now upon the request of one of my students who was answering this question, which is from one of my end of topic worksheets on straight line graphs, end of topic worksheet 3 from my Cambridge P1 material. And this is question number 6 from that material, from that particular worksheet, and it also corresponds to question number 4 from the October-November 2019 P1 paper. From Alexa, from Cambridge 9709, variant 11. Okay, so here we have a question about this trapezium ABCD, in which the coordinates of A, B, and C are 4, 0, 0, 2, and H, 3H, respectively. Okay, so they're actually marked as well. The lines AC, BC, and AD are parallel. Angle ABC is 90 degrees, and CD is parallel to the x-axis. Okay, so this is parallel to the x-axis. Okay, so it's a horizontal line basically. So this is parallel to the x-axis, so they're horizontal lines. Now, one of the things I can note straight away before I continue is that if these lines are parallel, then these two angles are interior angles. So this must also be 90 degrees. So I have to add up to 180. That might come in useful later on. Maybe, maybe not. We'll see. All right. Now it says find by calculation the value of h. So basically, they mean don't draw a scale diagram on a pair of axes and trying to work it out by calculation. So we want to find the value of what h is. H is the x coordinate of the point C, and 3 times h is a y coordinate of the point C. So how are we going to do that? Well, what we can do here is we can see that if we find the equation of line B, okay, of the line going through B over here, the equation of the line that passes through B and C, that should help us find the value of h, because h is a point in the line, and the value of x and y of the point C should, if we substitute in the equation of the line, satisfy that equation, and that should leave us with just one unknown, which is h. So the key to answering the first question here is to find the equation of line BC. I'm going to call that line 1. Okay, I'm going to say the line going through BC. I'm going to call it line 1. I'll just put out there line 1. Okay, so the equation of line 1, we need to find two things. To find the equation of a straight line, we need two pieces of information. Right? To find the equation of a straight line, we need two things. One of the things we need is the gradient of the line. And the other thing we need is any point on the line, any point on the line. And we actually have a very useful point on this line, which is the y-intercept, 0, 2. Okay, so how would I find, so of course, so now we have for line 1, okay, we have one of the things we need, a point on the line, which is 0, 2. So I know the y-intercept is 2. Right, we can use that straight away in our answer. Now, the other thing we need is the gradient of line 1, which is the gradient between B and C. Well, we don't have that gradient. However, we know that the gradient of line 1, okay, we can say line 1 is perpendicular to BA. Okay, we can say BC is perpendicular to BA. BC is perpendicular to BA. Right, so if I can find the equation of or the gradient of the line BA, I will be able to then know what the gradient of BC is, because if you know a gradient of a line, the line that's perpendicular to that line would be its negative reciprocal. The product of the two gradients will be -1. So I can say that the gradient of the line of BA, I can find that is going to be the change in y between these two values, which is 2 minus 0 over the change in x, which is 0 minus 4. The gradient, remember, is given by y1, or you can say y2 minus y1 over x2 minus x1. Remember, it's the y coordinates on the numerator. So the gradient of the line BA is going to be 2 over -4, which is -1/2. So therefore, the gradient of line 1 is going to be the negative reciprocal, which is 2. Okay, I know that the gradient of line 1 times the gradient of BA has to give you -1. Then it must be the negative reciprocal. So therefore, we can say that line 1 has the equation y equals mx 2x plus 2. Okay, that's the equation of line 1. Okay, so now if I want to find the value of h, I know h is the coordinate of c is h, 3h. Okay, and c lies on line 1. So therefore we can say it satisfies the equation of line 1. So I can replace the y with 3h, and I can replace the x with h, and I end up with an equation here. You have 3h equals 2h plus 2, 3h minus 2h equals 2. Therefore, h is equal to 2. So I found the value of h. So I know that the coordinates of c are 2 and 6. Okay, so c, I know its coordinates now are 2 and 6 because h is equal to 2. All right, and we can see that 2, 6 lies on this line. When I replace this with 2, I get 4 plus 2, which is 6. So 1 equals 6. That's fine. So we know that this point C lies on line 1. Therefore, we can say that h is equal to 2. So we have answered this part 1 of this question. Okay, now for the next part of the question, it says, hence find the coordinates of D. Now we worked out this equation of line 1 was y equals 2x plus 2. So we want to find the coordinates of D. All right, so I know that for D, because this line is horizontal, okay, and I know that the y coordinate of C is 6, then this must be the y coordinate of D as well. So we need to find the x coordinate of D. We know the y coordinate of D. And we could do this by using the fact that we know the gradient of the line AD. The gradient of the line AD, which I'm going to call line 2, is equal to 2, because it's parallel to this line. They're parallel. These two lines are parallel. Okay, line 1 is parallel to line 2. Therefore, the gradient of line 2, which I'm going to call this, is equal to 2. So we can work out the equation of line 2 by using y minus y1 equals m times x minus x1. Okay, so I can say y, because I know a point on AD, okay, the point on the line L2 is 4, 0. So I can use the point 4, 0, and I can substitute instead of y, 0, instead of m2, and instead of x1, I can substitute 4. So y minus y1 equals 2 times x minus 4. Now, all we need to do here, we don't actually have to find the equation of the line. We could do, but we don't really need to find it because the question just says find the coordinates of D. So all I need to do now is replace y with 6. I know at D, y equals 6. And then if I put y equals 6 in here, that will be the x coordinate of D. So I'm going to put 6 minus 0 equals 2 times, this will be the x coordinate of D now, minus 4. Okay, so now I can just say 6 is equal to, I can divide both sides by 3 actually after this, it'll make it easier for me. So I'll have 3 equals xd minus 4. Therefore, xd is equal to 3 plus 4, which is 7. So therefore, we can say that the coordinates of D are 7 and 6. And there is the answer to part 2 of this question. Okay, it's just using the fact that these are parallel lines, which they've told us. Even if they didn't tell us, we should know the opposite sides, or one pair of sides in a trapezium are parallel to each other. But they told us that they marked it for us, so we know that they're parallel. They have the same gradient. So the gradient of BC, which we found earlier, and the gradient of AD are equal to each other. So that's the way that I have thought of answering this question. There might well be other ways of doing so, but this is what came to my mind. And there is the answer to part 2 of this question. I hope that was clear. So part A, 1 of the question, we had to first find the value of h, which is part of the coordinate h and 3h lie on the point. They are the point C, coordinates of point C, which lies on the line L1. So we know that that point must satisfy the equation of line 1, which we can find by finding the gradient of line AB and its negative reciprocal, which would be the gradient of line 1, the line going through B and C. And we know that the point on line 1 that we have is the y-intercept, so we can just straight away put it into y equals mx plus c, y equals 2x plus 2, and then substitute the values of x and y in terms of h inside the equation of this line, because that satisfies the equation of the line, because it lies on the line, and thereby we found h is 2. That was the first part. And then second part, we use the fact that the y coordinate of D must be 6 because h is equal to 2. All right. So this was 2, 6. So that the coordinate, the y coordinate must be 6 because this line is horizontal, parallel to the x-axis. So therefore, we can find an equation for line AD, which is parallel to the line that we found earlier. So it has the same gradient and it passes to the point 40. So I started off beginning to find this equation. We don't actually have to find the equation really. We can just set it up and then replace the y with 6, so such that we can find out what d is, which is what our what is required. They didn't tell us to find the equation of line AD, just they told us to find the coordinates of d. So we did that and we got our answer. And I hope that was clear. Thank you for watching. Other questions from this particular end of topic worksheet you'll find in the playlist over here. Other questions from this particular paper, if I get to answer them, you'll find in the playlist that will appear in this region over here from October to November 2019. Other questions which are about straight line graphs from P1 at Excel, Cambridge, okay, CAIE, will be found in the playlist over here. You can subscribe to my channel by clicking on this link, and at the top of the video you'd have seen some links to another video which tells you how to use my channel in an efficient manner. Okay, so I hope you watch that and see what you need, either whether you're doing IGCSE or Cambridge or EdXL, whichever board you're taking. You should find some material that might be useful for you. Thank you for watching and see you soon.